Hi and Assalamualaikum. My name is Cikgu Rosaila binti Cikgu Ramli and these are my group members. Nur Hanani binti Mama Asri, Anastasia Nabila binti Suhaimi, and Nur Anis Fakia binti Abdul Mashid. Without further ado, let's watch my group's roleplay about Newton's Law.
How did the thing happen to just stay still before I hit this? I don't want to think anymore. I know what to do. Hello, Nani.
Hi Anis, what's up?
I just have some thought in my head at the moment. I thought maybe you could help me.
Sure, I'll try my best.
I'm wondering on how an object could sit still without moving, not until something pushes it.
Well, that is exactly what the first Newton's law is about. An object at rest remains at rest, and an object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced force. You know what? Actually, I can help you more with this. Do you want me to make a video of it? You know that's my favorite thing to do.
Oh yeah, I would love to. Thank you, Nani.
No problem. I hope it'll help you.
Newton's first law is also known as law of inertia. An object at rest remains at rest, and an object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced force. This means something will not move unless a force is acting on it, and something will keep moving at the same speed unless it is acted by a force. An object continues to maintain its state of rest or motion until it is acted upon by an external force. Well, in the previous case, the bottle was not moving. It didn't change its shape, size, or position until acted upon by an external force, which was Annie's hand.
I'm feeling so bored today. What should I do? Wait, why the marble is moving when I flick it? Does it have connection with what Suhaila said about the second law of Newton?
Okay Anna, I will explain to you again. Accelerates is causes when a constant force acts on a massive body. In the simple case, a force applied to an object at rest causes it to accelerate with the same direction of the force. This statement I mentioned just now can be stated as Newton's second law of motion. Do you get it? Okay. And Newton's second law of motion is represented by an expression. Let me show you. Okay, Newton's second law of motion is represented by an expression which is force equal to mass multiplied with acceleration. For an example, there is a box with 10 kg mass and we push it with force 13 Newton. If we want to find the acceleration, we must use this expression. Okay, the force is 13 Newton. The mass is 10 kg and the acceleration, we want to find the acceleration. And then we calculate it. We got 1.3 ms power with negative 2. Okay, for the second law, if there is no external force, force is 0. Then force is 0 since acceleration is 0. When acceleration is 0, then either there's two possibility here, then either force equal to 0, that is object at rest. Okay, the second possibility, the velocity is constant, where the object moves with constant velocity. Understand? Good.
Oops, I guess I can't go any further. It's not like I can walk on the water. Wait, what is it that makes me able to walk on this ground but not on the water? How am I able to move forward and backward easily on this ground? I could have just fell to this ground like I would into the water due to my weight. But how am I able to stand? What exactly happened when I'm walking?
Well, I guess I can help Nani in this case. First, Newton's third law of motion can be stated as every action has a reaction, which is of the same magnitude but opposite in direction. Anytime a force exerted on an object, that force is caused by another object. In other words, Newton's third law involves two different bodies. Now, let's take the example of walking on the ground. When we walk on the ground, our feet push the ground in backward direction. This is the force of action. As a reaction force, the ground pushes our feet in forward direction with same amount of force. It is this forward reaction force of the ground which enables us to walk on the ground. When you try to stand on water, you never press very hard because the water moves out of the way. So, you don't press hard and the water pushes back with equal force. Now, try landing on water. The water will not easily move out of the way, so you have to apply huge force to move it quickly. The water pushes back with the same size force. Landing on water at speed can break bones or kill you.
In conclusion, Newton's law has three laws. First law, or law of inertia, can be stated as an object at rest stay at rest and an object in motion stay in motion with the same speed and direction unless acted upon by an unbalanced force. From this law, we can find x component where sum of f x equals to 0 and y component sum of f y equals to 0. Second law is the quantitative description of the change that a force can produce on the motion of a body. From this law, we can conclude that F equals to ma, where F equals to total force, m equals to mass, and a equals to acceleration. Next, third law is every action has an equal and opposite reaction.